The mathematics used in modern computers is identical with the mathematics that was used in ancient Egypt. And I'll show you how that works. Today, when we write a number, we work in powers of 10 and place value. We have the ones, the tens, the hundreds columns. So if you wanted to say 472, we're really saying 4 100s, 7 tens plus 2 ones. But the way that this occurs in modern computers is not place 10 value, but place 2 value. So their powers are 1s, 2s, 4s, 8s, 16s, and so forth. So if a computer wants to think of the number 16, let's say, well, if a computer wants to look at the number, let's say 14, it's 1 8, 1 4, it's 12, 1 2, and no ones. This kind of arithmetic is appropriate for computers because they deal with electricity, which can either be on, represented by 1, or off, represented by 0. The flow of electricity or no flow of electricity, these powers of 2. Now, the way the ancient Egyptians developed this can be seen in the way that they would multiply. Now, neither the ancient Egyptians nor the modern computers use a times table. Times table is something we teach children in school, and it has to be memorized. But it's really inappropriate for a computer. And I'll show you how, for example, that works. The modern computer designers, as well as the ancient Egyptians, were aware of a mathematical fact that any number can be shown to consist of the sum of powers of 2. What I mean by that is if we write the powers of 2, 1, 2, 4, 8, 16, and so forth, you notice there's a doubling going on. And any number can be represented by the sum of these. For example, if we wanted to choose the number 17, it's 16 plus 1. So I can count 1, 2, 1 plus 2 make 3, 4, 1 plus 4 make 5, 2 plus 4 make 6, 1 plus 2 plus 4 makes 7, 8, and so forth. And so any number can be represented by this, the sum of elements of this sequence. So if I wanted to multiply two numbers, let's say we wanted to multiply 17 by 25. In order to multiply the way the Egyptians did and the way the computers do, all you have to know is how to double numbers like this and how to add two numbers together. No multiplication table needs to be memorized. So 17 times 25, I've identified the elements of 17 as 1 plus 16. And in this column, I write the number 25, and I just keep doubling it. Twice 25 is 50, twice that, 100, twice that, 200, twice that, 400. So in order to know the product of 17 times 25, we just have to look at which numbers are circled over here and circle the corresponding ones over here and add them together. So 17 times 25 is 400 plus 25, or 425. It's that simple. No memorization, no times table, no tears in the third grade about this. And this is how computers do it as well, except instead of circling or not circling a number, they would have a 1 or a 0. So in other words, the number 17 in binary arithmetic by computers is 10001. Or electricity, no, 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 and electricity. And that will give us the sum. And that's how this works. Now, division in computers or in ancient Egypt is just the opposite of multiplication. It's the inversion. So let's say we wanted to divide 1075 by 25. Now, we don't want to use the multiplication table, nor do we want to use any kind of long division. And the way to do it is like this. Simply write out the powers of 2, 1, 2, 4, 8, 16, 32, and so forth. Here again, just the powers, the doubling of 25, 50, double that, 100, 200, 400, 800. I stopped there because if I went further, it's 1600, which is larger than 1075. And if I know that 1075 is 800 plus 200 make 1000, and 50 and 25, I just have to look across at the numbers that correspond there, or in a computer there would be electrical circuit. And if I know that 32 plus 8 is 40, 42, 43. So 1075 divided by 25 is 32 plus 8 plus 2 plus 1, 43. No multiplication table, no long division, no carrying, no borrowing. It's just very straightforward. Now, how did the ancient Egyptians know this? Well, I might add that also the ancient Chinese knew this. The binary system of powers of 2 is also the basis of the trigrams and hexagrams of the I Ching. The flowing nature of the universe, how things turn into one another in a flowing process, in a binary kind of a pulsation. So this kind of arithmetic was also known to the Chinese as well. Now, did the modern computer people look to the ancient Egyptians or the Chinese? No. In fact, they didn't look to each other, but they all looked to the same place, and that is to the eternal principles of mathematics. And the Egyptians were quite adept at looking at eternal principles.
Hi, this is Presh Talwalkar. In this video, I'm going to explain a weird way that you can multiply numbers, known as the Egyptian method or Russian peasant multiplication. The interesting aspect is that you will be able to multiply any two whole numbers as long as you know how to divide numbers in half and double numbers. So let's do an example of 13 times 24. The method involves 4 steps. The first step is to take the number on the left and repeatedly divide it in half until you get to the number 1. So we'll take 13, when we divide that in half we get 6, and we'll ignore the remainder. When we divide 6 in half we get 3, and when we divide 3 in half we get 1, and we'll ignore the remainder of 1. So the first step is to take the number on the left and repeatedly divide it in half. The second step is to take the number on the right and keep doubling it. So the number 24 when doubled is 48. Then we're going to double this number again to get 96. And finally we double 96 to get 192. The third step is to modify our table by crossing out any row that starts with an even number. In our table, only the row that starts out with 6 is an even number, so we're going to cross out the entire row. The final step is to add the numbers in the right-hand column. So we need to add up 24, 96, and 192. And when we do that, we get the result of 312, and that's our answer. 13 times 24 is 312. Let's do another example to see how this method works. Let's say you wanted to do 16 times 26. The first step is to divide the number on the left in half repeatedly. So dividing 16 in half, we get 8, and then 4, 2, and finally 1. We take the number on the right, and we repeatedly double it. So from 26 we get 52, 104, 208, and 416. The third step is to cross out any row in our table that starts with an even number. And in this table we have a lot of even numbers. So we cross out the first row, the second row, the third, and the fourth row. The only row that remains is the last row, and so that's our answer, 416. And in fact, 16 times 26 is 416. So the short reason this method works is we're doing multiplication in binary. The long answer, I provided a link in the video description. I hope you liked this video. Please subscribe to my channel. You can catch me on my blog Mind Your Decisions or on Twitter @Presh Talwalkar.